Welcome back again. From our previous video, that is on this ancient structure, we did some observations. So again, we are here. I'm here. I've come back to do again some more observations on the structural components, or rather the structural elements of this structure. Although it is a dilapidated structure, it's a structure that it used to be occupied some 100 years ago, but actually at this point it is not being occupied. It has come down. It is actually not inhabitable. But I just wanted us to do again some more observations on this structure, or rather on this building. And being more precise, I'm going to carry out structural observation on this building. The story behind this building is that it was being occupied by one of the ruling sultans. And as I said, that is in our previous video, that is concerning this ancient building, is that most of it, the structural members of this structure, is that they really tried to avoid concrete. They really tried to avoid concrete, that is building this house. So I'm going to do some observations, that is on the structural members. When I talk of structural members, I mean the framed structure. The framed structure, that is comprising the beams, the slabs, the columns, the staircase. I mean, for those who understand structural engineering, when I talk of a framed structure, so a framed structure of a building. So a framed structure of a building, it is just a structure before you do the masonry walling. So it is either reinforced concrete members, or rather reinforced concrete elements, such as the slabs, the beams, and the columns. So I'm going to do that observation to see actually what really transpired on this building. Let me take this opportunity again to thank my viewers, and for those who haven't subscribed to our channel, please do so by just pressing the subscription button, such that when we upload any other new video, YouTube will automatically update you. Alright, so let us do the observations. Now we will start by observing the columns. Like yesterday, you see what I did, the observation that I did. Now you see we have arches here. This is the porch, and from the previous video I said that I didn't, or rather I don't know whether it was an exit porch or an entry porch, but all in all it is a porch. So it is a porch having arches. It is a porch having arches. So you can see these are arches. So the observations, the first observation that I want to make is about the support of this arch. So as we all know that arch can be supported either by using, we can support the arch either by using masonry columns. Masonry columns, I mean that columns constructed from masonry, either using blocks or bricks. And then also arches can be supported using reinforced concrete columns. So arches also can be supported using reinforced concrete columns. But now the observations from this arch, just observe it carefully. This is an arch on top of us. So the observation from this arch is that if you look at this support, you are not able, or rather I'm not able to see any concrete in this support. I'm not able to figure out concrete, but what I'm able to figure out is actually boulders again, or rather rubbles brought together, that is using cement sand mortar, and then it was done to come up with a column, or a column support. So this is one of the observations that I discovered. So you can see this arch. This arch, it's like the support is a column, but a column that was done using rubbles, and these rubbles, they were just connected together using cements and mortar, which means it's like they really avoided using concrete. They really avoided using concrete. But again, when you look at the arch itself, if you look at the arch itself, again it appears it's like it was concrete. But then this concrete, if you look at the ballast, or rather if you look at the aggregate that was used, it's actually, I don't know, for those who are conversant with materials, this aggregate that was used to come up with this arch, or to come up with the concrete for this arch, you can observe it. How does it look like? Anyway, my point was that for the support of this arch, that is the pillars, or rather the columns were not done using reinforced concrete, or even it was not done using maybe a block or rather bricks column, because sometimes we also do a brick column, or we can do a block column. That is a column made of blocks or bricks, such that can support the arch. But with these modern days, mostly we use the reinforced concrete column, that is to support the arch, and even the arch itself, it might be done using concrete. But this is a very crucial observation. So this is one of the observations that I discovered. You see this support for this arch, it is not reinforced concrete. For me, what I see, it's rubbles that were brought together, binded by cements and mortar to come up with the column support for this arch. So this is one of the observations that I discovered. And then again, I cannot dispute that there was no concrete that was used here, because again, let us do this observation. Let us go and observe one of the columns, because I saw something like reinforcement. I saw something like reinforcement on one of the columns. Here is the column. So you can see this column. This column, if you observe it carefully, you see this is a reinforced bar, or rather it is a reinforcement. This is a reinforcement that actually has undergone corrosion. So the observation here, it's a column. The observation here, you can see, I don't know, was this concrete, or are they again rubbles brought together using cement and mortar, and then it was reinforced? Because this is also another observation that I discovered, but it's not really coming clearly to me. So is this concrete, or these are just rubbles brought together using cement and mortar, and then it was reinforced? But actually, as we know, is that concrete is good in compression, while reinforcement, or rather the bars or the rebars or the reinforcement bars, are good under tension. So, and this is the reason why reinforcement is normally used together in concrete, because the bonding is actually good. It was discovered that the bonding that is between the concrete and the reinforcement bars is good, and actually they work together, that is to counter both the compression and the tensional force. But concrete, actually it's good to counter the compression force, and the reinforcement or the steel that is put inside concrete is good to counter the tensional forces. But now for this observation here, you can see this column. For this observation, was this concrete or was this rubbles brought together, but it was reinforced? So from the comments, please help us understand this observation here. Okay, apart from that, now we will go back inside and do an observation that is on the slab, because again, the observation that I did from the previous video is that I was trying to guess, it was not coming out clearly whether the slab was a composite slab, because again, you remember, let us go inside and see. You remember I said a composite slab is a slab that has been constructed, or is a slab that has been done using more than two materials. Let's say if it's a composite slab that has been done using timber decking, or if it's a composite slab that has been done using steel decking and then with some concrete reinforcement and concrete, or if it's a timber decking and then with some concrete which is reinforced. But for this one, let us do this observation. So you see, this is the slab. This was the slab. This was the slab. You see, the slab actually is being, or rather it was being supported by timber. So it's like they did timber decking, and then that's how they came up with the slab. So the timber decking, you can see this timber decking. So, but I'm not able to see, or I'm not able to visualize the concrete. Or is it because of the material that was used? It has become difficult to identify the concrete. But again, I'm not even able to identify the reinforcement bars that were used, that is on the concrete. But what I can see is that I can see a layer of, again, broken rubbles, and also I'm able to observe a layer of screed. So actually, this again one of the observations that I discovered. So it's like it was a composite slab, but again, the way it was done, it's actually amazing. So it is a building that was done some, let's say 150 years ago. It was being occupied by one of the sultans, and something that, or rather the interesting thing is that I just want to know, to discover or to understand how this building was done. And in terms of materials, for those who understand the materials, or rather the characteristics of the materials, I would like to know from the comments, does hardwood actually rot? Does hardwood actually go bad? Or what is the lifespan of hardwood? Because again, I'm not able to ascertain whether, if these timbers that were supporting the slab, I'm not able to ascertain whether they were hardwood, or because actually softwood can't actually suspend a slab. And again, you see the way the slab was being suspended, the way the timber deck was done is that you see the depth of the timber is actually bigger than the breadth, which means it was actually able to counter the flexure, or rather the flexural failure. The same way reinforced concrete beam works. Of course, the depth of the beam is supposed to be more than the breadth of the beam, such that it counters the flexural failure, or rather such that it works nicely when it comes to flexure. So let us go inside and do more observation on the slab. And then again, before we go inside, you see what I said again in the last, or rather in the previous video, is that this building, they actually avoided using lintels, or I could say beams, or reinforced concrete beams. Like you see this wall here, but I don't know what actually was the meaning of this But as you can see, it's like this wall is being supported by timber again. It's like a pole, a timber pole supporting this wall. And actually for this loading to be sustained, or rather for this loading to be carried by this timber, is this timber, what could have been the type of this timber? Is it hardwood? Of course I rule out softwood, because actually for softwood withstanding such kind of a load, it's not easy. And also from the comments, please my viewers, I would really like to understand what is the lifespan of hardwood, and does hardwood rot or does hardwood decay? Of course we know some examples of the hardwoods that we do have is mahogany, cedar, I don't know, Elgon teak. Yeah. So alright, let us go inside and do more observations. Let us go inside and do more observations. Actually, the purpose of this video is to do the structural observation. Not structural analysis, because if we talk of structural analysis, that means something different. When it comes to structural engineering, somebody will interpret it wrongly. So it's better we use the term structural observation, not structural analysis. So here we are inside. So as you can see, it was a high-rise building. Let's say it's like is it a two-story or it's a single-story building? Of course we have, so you can see there is no beam, there is no reinforced concrete beam. Of course we understand, yes, the walling were very thick, or rather the wallings are very thick, such that they can withstand the loading. But again, when it comes to the beams, you can see even on the windows were being supported by timber. When I talk of timber, I mean the lintels that actually the beam that is supposed to carry the loading, that is on the window. You see, they were using timber. So they really avoided concrete in general, or reinforced concrete. So they were using timber. So you can see this window. What is supporting the load on top of this window is timber. Again, you can observe that point is that we have timber. We have timber. So actually reinforced concrete was really avoided here. Reinforced concrete was really avoided here. So this is actually again another observation, is that the beams were not used. Let me be specific, the reinforced concrete beams, the RCC beams, were not actually used. Instead they used timber to carry the loadings. Like you see, this appears like it was a door, or rather not a door. Would I say again, it was just an opening, but you can see this opening. Let me move clear, or rather let me move near so that you can be able to see. You see, even the timbers at this point, they are warping, because I think they have gone bad, or rather they have decayed, or they have rotten. And that's why I'm asking the question. I really like to see from the comments, does hardwood timber decay, or does it rot? Does it go wrong? From the materials perspective, characteristics of materials, and what is the lifespan of hardwood timber. So you see this point here. It's a place that actually is supposed to be supported using a beam or a lintel, but instead they used timber. Okay, let's do an observation on this slab. You can imagine this was a slab. You see the slab, actually, we said that it was on a timber deck. But another structural observation is that you see the thickness of the walling. That is the walling that is on the lower part, is that the thickness of this walling is very massive as compared to the walling upwards. So it's like the thickness of the walling downwards, it's more thicker, let's say maybe 600 millimeter thick, and on the upper side the thickness of the walling, it reduces to maybe like 400 millimeter thick. So in terms of structures, or rather structurally, these people actually, they had an idea when it comes to structures, because as you go higher, actually the loading is supposed to reduce, and of course the bottom walling is thicker, such that it can be able to support the upper walling, which is somehow less with less thickness. So the lower wall is more thicker, let's say 600 millimeter thick, and the upper wall is like 400 millimeter thick. So this observation is a good observation. It's like also these guys, they had some structural ideas when it comes to actually to the loading. And also I'm being informed that this ancient building is that it used to have a basement. It used to have a basement. And as you know, a basement, of course, the walls that support, or rather the walls to do a basement, they are supposed to be good walls that can carry, or rather that can withstand the lateral pressure from the soil. So this could be true, because you see the thickness of this walling, especially the lower part walling, is 600 millimeter thick. So actually, if this building had a basement, actually this basement could be still existing, because the walling is so massive, it can withstand the lateral pressure, because it's like a gravity retaining wall. So they used gravity retaining wall actually to do the basement for this ancient structure. So this is also another observation that we have done. All right, again, from another observation is that when it comes to mortar, the mortar that was being used actually to do the walling, nowadays we understand the mortar is from the cement sand mortar, and actually it normally goes with a certain ratio. But on this ancient building is that another observation is that the mortar that they used to do the walling, to bind together the rubbles to come up with the walling, is that they were just using sand and lime. So this is also another observation, or rather it's another thing that also I'm being informed with my fellow observer. So you can see they used sand and lime. So it's like there was no cement. So they just used sand and lime to come up with the mortar. So there's also another observation. Actually, you can see this is a walling, and it goes all the way without being supported by any reinforced concrete. Very, very amazing. It's a walling going all the way without being supported using any reinforced concrete. All right, let us continue with our observations. You see, what I was saying is that here we are supposed to have a lintel, which is a reinforced concrete beam, but instead it is timber. And another observation that I was talking about is the thickness of the slab. You see, the slab was actually very thick, and the layers of this slab I can't even ascertain, or rather I can't even know, because the thickness of the slab is too thick, which means this wood actually it was able to withstand this loading. The wood was able to withstand this loading. So that's why I'm not ruling out that this could have been hardened, because this slab is actually also massive. It's very thick. It's almost like half a meter thick, and you can see they didn't use beams. But we understand the wall thickness were very big. The wall thickness were very huge. That is also almost a half a meter thick. That's the thickness of the wallings. So these are some of the structural observations that I really wanted to do. And from the comments, I would really like also you to help me understand. So this is a structural observation on a very ancient building that was being occupied by one of the sultans that was ruling the coastal towns that is within Eastern Africa. So now let us observe the roof slab. I don't know if you will be able to observe it, or rather if I will be able to capture it very clearly. The roof slab, you can see the roof slab. The roof slab actually, again, it was supported by timber, and this timber, you can see the spacing is very close. The spacing is very close, like 200 millimeter apart. But I don't know what was the thickness of the roof slab. And also from here you can observe the thickness of that arch. You can see that arch is almost half a meter thick. So a lot of loading, but actually reinforced concrete structural members were not used. But it's a very heavy building, that is in terms of loading, because the wallings are very thick. So from the arch you can observe, and it was like a two-story building. So these are the observations that I really wanted to do, such that people can help us from the comments analyze how this structure was able to be done. I don't know what were these used for. Also, another thing is that I would really like to see or to observe the staircase, but I cannot access the staircase. But it's also a good observation that we might, or rather I might do, because I would really like to understand how the staircase were done. Because actually here, from my observation, is that they really avoided reinforced concrete. They really avoided reinforced concrete. What they used is just massive walls that were done using rubbles and suspending the slabs using timber deck, and also the windows and the door openings, they were being supported by timber and not reinforced concrete lintels or reinforced concrete beams. So from the comments, help us understand. This is just an observation. You can see this is part of the slab. It was supported by timber. So as I was saying, the walls were load-bearing walls. You can see the thickness. This is an internal walling, but you can see the thickness. So I think that is the reason why it was able to carry the loading, and that is why they actually avoided reinforced concrete. So these are some of the structural observations that I wanted to make. So we have done structural observation on the columns, we have done structural observation on the slab, we have done structural observation on the lintels, and again we have done structural observation on the support of the arch, because we said, or rather what we observed is that the arch is not being supported by reinforced concrete columns. It is being supported by columns done using rubbles. Alright, let us try and see. We observe it from the other side. I think from here you can observe it well. You can see that is the arch. Very, very massive. And you can see the way the roof slab was supported. It was supported by timber deck. Also from here you can be able to observe very well the lintel. It's a, can I call it timber lintel, or you see that opening? That opening, the loading on top of it is being supported by timber, and it's not a reinforced concrete beam. So from the comment section, was this hardwood, and does hardwood decay, does hardwood rot, and what is the lifespan of hardwood? Because I understand that this building is like, it was done like some 200 years ago. Of course, it is not habitable. It is not habitable, but that is, I want to understand some of the characteristics, material characteristics of hardwood, if at all this was hardwood that was used, in terms of what is the lifespan of hardwood, and does hardwood rot or does it decay? And then when it comes to load bearing walls, you see the walls are so massive. The walls are so massive, and actually these walls were being done by rubbles. Alright, as we sign off, I just want to say thank you, and please continue subscribing. Please like, comment, and share widely.